In this video, I would like to speak about the confidence interval and the Z value. These are important because in the coming video, I will speak about estimation of the sample size or calculation of the sample size based on the population proportion, in which we use the Z value. So it is important to understand the confidence interval and the Z value. The confidence interval is a range of values. It is a range of values that contain the population mean. The confidence interval is a range of values that most likely, most probably, with very high probability that it contains the population mean and the data around the mean. And let us give an example. In diabetic patients, we are 95% confident that complete surgical wound healing would occur between 8 and 14 days. We are pretty sure, we are confident enough, we are 95% confident that complete healing will occur within these limits, 8 days to 14 days. 8 is the lower limit and 14 days is the upper limit. 14 is the upper limit. So within this interval, we are confident that 95% the mean of this population of diabetics will lie within this interval of 8 to 14, and the data around it, 95% of the estimates of the data around it will lie within this same interval. That is to say, if we repeat the study several times, if we repeat the study many times, 95% of the results would fall within the same range, within the same interval, within the same 95% interval. That is 8 to 14 days. Few patients' wounds might heal before 8 days, and few patient wounds might heal after 14 days. But 95% will heal, including the mean of the healing, of the days of healing, will be within this range, within these two limits. Usually, we take the general population as homogeneous with irregular data. And if we plot these data in a diagram, it will show an inverted bell shape with symmetrical edges. Inverted bell shape with symmetrical edges. And when we speak about 95% confidence, this means that 95% of our estimates, including the mean, will lie within this bell-shaped graph as shown in the blue shadow in the diagram in front of us. That the mean lies there right in the center, and 95% of the estimates lies around the mean, and only 5% lies outside these limits, outside the upper limits of our confidence interval, outside the upper confidence limits or lower confidence limits. And usually in such a smooth bell-shaped diagram, the amount of estimates outside our 95% confidence is 5%. It will split equally into two halves, equal halves, each half in one above the upper limit and one below the lower limit. That the 5% remaining, 95% confidence will be in the blue area. The remaining 5% out of 100 will be split into two equal halves. 2.5% will be in one above the upper limit, and 2.5% will be below the lower limit. I hope this is clear now. Again, the confidence interval means that the mean lies within the range of the confidence interval. When we speak about 95% confidence interval, means the mean of the population or of the estimates lies within the confidence interval, within the limits, within the boundaries, within the bounds of the confidence interval, with 95% of the estimates of the data lying around the mean in the same range, and only 5% lies outside these limits, and the 5% will split equally into two halves. Each half will be in one half, that is 2.5 above the upper boundary or upper bound or upper limit, and 2.5% will be below the lower limit or lower bound or lower boundary of our 95% confidence interval. The confidence interval, it contains the mean and 95% of the estimates around the mean. So the difference thing is that this 5%, which we find in the peripheries, they create significant difference. Let us say again, 95% confidence level means we are speaking, when we speak about 95% confidence level, we are speaking about 95% confidence interval, which describes how certain we are that if sampling is repeated many times, if it is repeated several times, 95% of the results of the estimates of the data would lie within these limits, within the 95% confidence interval. And only 5% will lie outside and will split into two halves, each half above and below each of these tails. And this 5% is a significant difference. I hope it is now clear. Now we want to speak about the line, where to draw the lines that cut off the 5% from the 95% confidence interval. The line that demarcate the boundaries or the limits of our 95% confidence. This line is marked or demarcated or is shown by what we call the Z value. At the Z value or Z value 1.96, there is a cutoff. It makes the boundaries the upper and lower boundaries or upper and lower limits of our 95% confidence interval, so that the mean lies within the confidence interval, within this area, in this diagram in the white area, and the data around it, the estimates, 95% of the estimates will be around this mean. The mean at the zero level there at the center, because it is a regular shape, inverted bell-like, and half of the data on each side, that is 74.5% of the data on each side. The distance of the data of each datum, single datum from the mean, is usually measured by the standard deviation. And the Z value is a measure of the units of the standard deviations. So it works like the standard deviations. However, it is bigger than the standard deviations. It is a measure of units of standard deviations. We will understand it in the coming slide. And the Z value or the Z value is a measure expressed in standard deviation units. Standard deviation units, to show how far a point or a datum exists from the mean. Now, if we look at the bottom of this diagram, on the left-hand side, the standard, as the Z value moves 1 unit of standard deviations, 1 unit to the left, and then it moves 2 units to the left. 1 unit to the left and then 2 units to the left. Before completing the 2 units to the left, in the lower part of the diagram on the left-hand side, before reaching complete 2, exactly at 1.96, there is a cutoff between our 95% confidence interval and the significant 5% that remains outside, or in fact half of the 5% that remains outside. On the bottom of the diaphragm, also on the right side, we see the Z value has moved 1.96 units of standard deviations to mark a cutoff between the confidence interval and half of the significant difference. So these boundaries between plus and minus 1.96 lies our confidence interval, in which 95% of all estimates of all the data, including the mean, they lie within this area. And only 5% being split into 2 equal halves, each half, that is 2.5%, 2.5%, lies outside the limits of our confidence interval, making significant changes at each tail. 2.5% means 0.025. We'll see this in a minute. So, the Z value is simply a measure using standard deviation units. Standard deviation units to show how far a point from the center is. How far a point is from the center, from the mean. Now, at the center, at the 0 level, is the mean. The mean is there at 0 level, and at this point, Z is equal 0. Now, when Z value, the critical Z value, moves 1 unit of standard deviations to the right, when it moves 1 step into the right, it becomes +1. +1 standard units. And if it moves 2 steps to the right, it will be +2 standard units. And if it moves 1 unit, if it moves 1 unit to the right, it is +1. If it moves 2 units to the right, it is +2. If it moves 1 unit to the left, it is -1. If it moves 2 units to the left, it is -2. Now, let us see it in this diagram again, repeated. At the bottom of the diaphragm on the left-hand side, the Z value has moved 2 steps to the left. 1 minus, 2 minus, but before reaching the end, before reaching complete 2, at the point of -1.96, there is a cutoff at the lower boundary of our confidence interval. And at the bottom of the diagram, on the right-hand side, we find out the Z value has moved 1.96 units of standard deviations to reach a cutoff point for the upper boundary or bound or limit of our confidence interval, 95% confidence interval, at this point, which is equal 1.96 Z value, outside which there is 2.5% significant difference. So within these limits of ±1.96 lies the confidence, 95% confidence interval, within which we find the mean and 95% of the estimates or of the data around the mean. And only 5% statistically significantly different lies split into 2 halves, each half at each tail. The significant difference. We call this 5% alpha. On the normal curve, the 5% outside the Z cutoff, which is 1.96 for 95% confidence interval, 1.96 standard deviation units. We call this 5% alpha. And I said in the general population with a homogeneous population, a normal distribution of data, it is split into 2 equal halves. Each half, 1 half above the upper limit of our 95% confidence interval, and the other half, 2.5% at the lower limit or bound or boundary of our 95% confidence interval. And I said the 2.5 confidence is equivalent to 0.25. Let me remind you, we take usually 1 equal 100%, right? 1 equal 100%. Half this 1 is 0.5. It is equivalent to 50%. Equivalent to 50%. And 5%, 50% equal to 50% equal to 5.5. Then 5% is equal to 0.05. And half this 5% is 0.025. Just to remind you. Now, here it is shown more clearly in this diagram that in 95% confidence level, we are speaking with 95% confidence level, or it is written also as 0.95. We have a range of values That range is 95% confidence interval, in which we find the mean and the data around the mean. The 95% estimates around the mean. Remaining only 5% difference, which is statistically significant difference, and that is split equally into two halves, each half above and below the limits of our 95% confidence interval. That is 5%, that is alpha divided by 2 above the upper limit, and alpha divided by 2 below the lower limit. That is 2.5% above the upper limit and 2.5% below the lower limit. That is 0.025 above the upper limit and 0.025 below the lower limit. And the cutoff is demarcated by the Z critical value of plus minus 1.96. This is important to remember. It is very easy. It is one figure to remember because we are going to face it in the coming video for calculating the sample size based on population proportion. So I said alpha is 5%, and usually we take the statistical significant difference as equal or less than 5%. It is equal to 0.05. Alpha is the probability of not containing the population parameter at 95% confidence. It is outside the 95% confidence. This 5% risk of uncertainty is divided into two equal halves as I described them before. And the line that cuts off, that demarcates the limits of our 95% confidence interval is the critical Z value equal to plus minus 1.96 that cuts off 5%. 5% being splitted into two equal halves, each half at each tail, 2.5% at each tail. That is 0.025 at each tail. Let us go back to our previous example. As I said, in diabetic patients, we are 95% confident that complete surgical wound healing occurs between 8 and 14 days. And therefore, the upper and lower limits are 14 and 8 respectively. The upper limit is 14 days and the lower limit is 8 days. And the mean, when we take 14 plus 8, is equal to 22 divided by 2, it is 11 days. Mean. It lies, the mean, and 95% of our data will lie within our 95% confidence interval. And only 5% will lie outside. And the cutoff will be demarcated by, or will be marked by, the Z critical value, which is 1.96. We take this value particular for 95% confidence. If we speak about more confidence, the Z value will change. If we speak about less confidence, the Z value will change. The Z value will increase with more confidence. If we move from 95% to 99%, it will become bigger, more than 1.96. And if we come down from 95% confidence to only 90% confidence, the Z value will become smaller. It will become less than 1.96. Let us see this. Usually confidence is taken either 99% confidence or 95% confidence, or 90% confidence, and usually it is taken 95%. Commonly it is used as 95%, commonly. However, sometimes for high precision, for high accuracy, when we are very sensitive about the results of the data, we can consider 99% confidence. And if we have some difficulties, we can come down to confidence of 90%. So 99% confidence level is used for more accuracy, for more precision, as in financial and in drug research. In financial and drug research, we do not want to make any mistake. Any mistake will carry bad consequences, will carry bad or serious consequences. But when we go for 90% confidence level, z-value will become less. And we use 90% confidence level if we have some sort of difficulties. We use it to balance some sort of uncertainty or some sort of difficulty in high precision, or some sort of high cost, and or some limitations in the study, or any other difficulties. We can go down to 90% confidence. So the confidence is only, commonly it is 95%. It can be as high as 99% or as low as 90%, not more, not less. So the z-value, as I said before, it is different with the level of confidence. As is written here in green in the middle, at 95% confidence level, the z-value is equal to plus minus 1.96. Known, easy. When we use confidence interval less than that, just 90%, the z-value will become less. It will be only 1.6. It is less than 1.96. It will be 1.645. And if we use high confidence level, 99% confidence level, as in financial finance and in drug research, then the z-value will also be high. It will be 2.576, more than the z-value of our 95%, which is 1.96. I hope this is clear, and I need you to remember the z-value for our upcoming video on estimation of the sample size based on the population proportion. I will explain this and discuss it in the coming video. The z-value is the mathematical number that guarantees the results to be correct. The z-value guarantees the result is correct at 90% or 95% or at 99% confidence, or 90%, 95%, 99% of time, or at 90% of probabilities, 95% of probabilities, or 99% of probabilities. So it is important for us for accuracy of our data and of our research. To this point, I will stop, and we'll see you in the upcoming video.